finding the limit, we want to take that 0 for number 1 and plug it into x. So that's going to give me 0 squared plus 3 times 0 plus 5. 0 plus 0 plus 5, that's just going to equal 5. Now, a limit at infinity is a little different. So infinity plus 7 over infinity squared minus 8. Now, infinity plus 7, that 7 really doesn't matter that much, so I can ignore that 7. And infinity squared minus 8, that minus 8 really doesn't matter. So I'm just going to look at infinity squared over, infinity over infinity squared. That's going to simplify. 1 infinity over infinity squared will simplify to 1 over infinity. 1 over infinity is actually equal to 0. Plug it into 2, you plug in the 2 into the top, that's going to give me 4. 2 squared is 4, 4 minus 4, over, plug in the 2 on the bottom, and that gives you 2 minus 2, so that gives you 0 over 0. Oops. That means we have to do something else, all right? 0 over 0 gives you an oops. You can't have 0 over 0. So what we're going to do is we're going to factor the top. So if you factor the top, that'll give you x plus 2 times x minus 2, all over x minus 2. Notice, these will simplify. And that gives you the limit, as x approaches 2, of x plus 2. Now when you plug that 2 in, you get 2 plus 2, and that's going to give you 4. The limit as x approaches 3, if I plug a 3 in there, that would give me 9 minus 9 on top, over 3 minus 3 on the bottom. That gives me 0 over 0, and that spells oops. That means we have to do something else. You're not allowed to do the 0 divided by 0. So what we can do is we can factor the top. So if we factor the top, that would give me x plus 3 times x minus 3, all over x minus 3. So the x minus 3's cancel out. So the limit as x approaches 3, I plug into that, and that's going to give me 3 plus 3 equals 6. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to use the slope template. I'm going to set up a slope template here with a minus sign and a minus sign. And then y sub 2 is 9. Y sub 1 is 7. X sub 2 is 3. X sub 1 is 2. So 9 minus 7 is 2 over 1. So my slope is going to equal 2. Average rate of change is also slope. This is an x value, and this is a second x value. So I have my x sub 1 and my x sub 2. So to do average rate of change, I'm also going to set up my slope template. I have x sub 2 is 4. I have x sub 1 is 2. See how I get that from my slope formula? Now I need to figure out what to put on top here. So I take this 4, and I plug it into x squared. So 4 squared is going to be 16. 4 squared would be 16 there. I take this 2 and I plug it into this. So 2 squared, that would be 4. And now, I'm just going to do my normal arithmetic. 16 minus 4 is 12. 4 minus 2 is 2. 12 divided by 2, that's going to give me 6. So my average rate of change is a slope of 6. Derivatives, so y prime equals, going to do the power rule, 3 times 5 is 15x. You subtract 1, so 15x squared. The derivative of 3x is just plus 3. And the derivative of negative 9, or 9, is 0. So that's your answer. The derivative of e to the x is very strange. It's just e to the x. The derivative of ln x, that's an L, that's an N, and that's an x. If you cross out the N, it looks like 1 over x, sort of. The derivative of ln x is 1 over x. Trig derivatives, y prime, you're going to want to use your trig chart. So sine, cosine, negative cosine, and sine. And these are derivatives going down. So the derivative of sine x, I just go down 1, it's going to be cosine x. The derivative of negative cosine, I go down 1, it's going to be plus sine. That's a very brief look at calculus 6.